My name is Liongosari. I'm the Chief Research Scientist of Accenture Labs. Appreciate this morning you're joining us despite all the difficulties with the transportation. But we're very excited to bring you this particular topic. I think this is the first time in this particular event that we talk about artificial intelligence. So what we try to do here for this event is to talk about deciphering artificial intelligence. What it is, how is it being applied, how is it actually any different from analytics that we have been talking for the past 2 years or so. So try to sort of bring it alive. So with that, let me see if we bring the slide up. There you go. So what the first thing that we actually want to do for this session is just talk a little bit about AI, give you sort of a quick overview what it is, so that we can settle on definition. Obviously, there are many definitions of what artificial intelligence is, but I'm going to try to bring it alive. And then we're going to spend about 20 minutes or so asking questions around how AI is being applied in a real situation. We have three beautiful panelists here, talk about their experience, the challenges that they have, what is their journey look like? How is it actually different from analytics work, especially in terms of the skill set, in terms of the capability, and sort of all of the pieces that have come together to create the solution that is actually AI-based. So what we have today is to show you one particular definition of AI, and this is coming from my favorite code. And there are many of those, and the reason why I like this particular definition is mostly the fact that it is about things associated with people acting intelligently. It is not about computer being intelligent, very different, okay? It is about how to create a systems and application that actually have a feeling of intelligence in it. Now, whether the application itself is intelligent, that's a very different story, okay? And there's actually quite a bit of subtlety of how to make that happen. And one of the things that's really critical is the fact that artificial intelligence is not one thing. It is actually many, many things, okay? And there are things that lend naturally to analytics, and we're going to talk about, for example, machine learning, which is actually really the hot topic of AI today, specifically around deep learning and how the infrastructure actually be able to accelerate that process. But there are others that are typically not associated with analytics. For example, knowledge representation, reasoning. So earlier in the session, Sam Josh talked about how Steelcase be able to create intelligent services in the room. Remember that? And one of the things that we typically do not have in typical traditional analytics is the fact that the sensors, like in this room, be able to sense the amount of number of people. Perhaps you have a room that's too small for the amount of people that you have in the room. And then the system can suggest that you have a room available out there that you can move the people if it's under the right circumstances. That is intelligent systems, okay? It's not something that you explicitly program. It knows the number of people. It knows the notion of people. It knows the notion of rooms and the capacity and all the stuff, and infer that there are things, certain set of actions that you can do. So that's an example of what traditional analytics and artificial intelligence. Now, obviously, this is just on the very surface of definition, but there's a lot more that we can talk about. So with that, what I will do is I will ask our panelists to introduce themselves and their role in artificial intelligence. So I'll start with Michael.
Okay, good morning everyone, bon dia. My name is Michael Loughlin. I'm from Nelmia Robotics Insight. Nelmia is we are an advisory, an independent advisory involved with looking for and helping our end users find new applications for robotics. And obviously robotics and artificial intelligence are very much go hand in hand. And artificial intelligence is bringing a lot of new capabilities to robotics. So what we're about is finding new applications out of the typical factory where robotics has been since the 1960s. And we're starting to see applications for robotics in healthcare, in farming, in all sorts of different applications, in security, where users need a helping hand in getting going with their implementation of robotics. So that's what we're about. Okay.
So next, Tilak.
Thank you. My name is Tilak. I'm a founder and CEO for a company called Predii. Predii is a purpose-built AI product designed for repair and maintenance of complex industrial equipment, and that's only one thing we do. So we're seeing quite a bit of transformation in industrial equipment and cars because of technologies like advanced, driver assistance systems, all kinds of sensors in the cars, and same thing goes to industrial equipment. With this complexity, we're seeing the change in the failures, how they happen as well. So we're also seeing advancements in the failures, so they're complex. So Predii is all about failures, and so that's what we do. We try to anticipate failures and how we help technicians fix them. And we use AI at the core in forming all these correlations and being able to help anticipate failures and also assist the technicians in fixing these failures. Thank you.
Thank you. Robert?
So I'm Robert Gimeno. I'm from Accenture. I'm a managing director there, leading the IoT analytics practice. So basically what we do is we run a lot of innovation sessions for our customers where we find real cases where to apply AI and analytics. So we have teams of data scientists. We use the right platforms to deliver that, and then we just generate those opportunities for our customers.
Wonderful. All right, so what I will do is actually for the next couple of minutes, is actually go to a couple of key questions just to ease into the topic of AI. And then we're going to go very specific in terms of different areas. And if you actually notice that each of these panelists have a different specialty. Right? For example, Michael is actually more around the robotics, and then Tilak with prediction and all the maintenance. And then Robert's actually more general term analytics there. So there's a very different aspect of it. So I'd like to start with Michael in terms of your thoughts around artificial intelligence. How is that going to relate to the robotics? Obviously, they are very tied together. But how do you see that in terms of the journey, in terms of what actually the implication of AI into robotics?
Well, I think for me, AI is a very, as you've already defined, is a very ample field. And really for robotics, I think the most interest is from the emergence of machine learning around the 1980s and latterly with the emergence of deep learning, which is giving a lot of opportunities to find applications in robotics for machine learning and deep learning, basically. The sort of applications we're seeing, obviously, are vision systems, which have been around and which are now capable of actually teaching themselves, of being able to, for example, bin pick random objects from bins, which is the normal way that objects would arrive to a production line. And the vision systems have reached a stage where they can actually learn on the job to actually increase their efficiency in pick operations. We're also seeing robots in transportation. Obviously, there are many applications in transportation, but the machine learning aspect of artificial intelligence for transportation is very important, and we're hoping to see great advances in this in the very near future. And also, basically, a robot, for us, the concept of a robot is a machine which senses and then acts, senses, thinks, and acts on what it's actually sensing. So obviously, increasing the sensing capability, increasing the possibility of perceiving what is in the environment is extremely important. And here, machine learning and deep learning is very important to actually achieve these aims. The other aspect of robotics is the interface with a user. Obviously, as robots, we are looking towards a future whereby the interface that the user will have with a robot will be completely just like the interface we have between humans. And we are striving to reach these aims using all the aspects of artificial intelligence, which give us capabilities for for natural language processing and so on. So I think there's a great tie-up between robotics and these aspects of artificial intelligence, and we're seeing great advances in this field.
Great. Tilak, you want to?
Yeah, I think so. It's two parts to your question. So one is what is our journey, and then the second is the challenges. So our journey is essentially, if you go back to the definition of AI, is about learning from experience, right? So the experience, in our case, we live in the world of, as I said, failures. So the experience comes from what did the technician found in the field, right? That's called servicing records or servicing information. The second part is data coming from the sensors, if it is an IoT-based equipment, or if it is a car, data coming from the canvas. So, and then plus the third type of experience is what did the OEM or the manufacturer of the equipment documented as these failures and procedures to fix these. So we gain experience. I mean, that experience becomes the input, and the output comes is the intelligence. So what did we produce? What are the correlations we formed? How do we anticipate the failure? So if you think about the input and output, that is essentially how we view the world. And we started the journey with that. When we talk to customers, we look at those two sides of it. What is the type of data you've been collecting, and also what is the objective for you with respect to the intelligence that's being produced? So those are the two things. So when it comes to challenges in the industrial equipment or even in the cars, these are mission-critical assets or mission-critical equipment. So the false positives are really sensitive in this case, and you cannot predict something that, to fix a particular problem and it happens to be not true. So these are fairly fatal implications. So for what we noticed is, compared to the other industries, we're dealing with highly precise, results are expected here. Most of the algorithms that come out of the box from artificial intelligence, they're not meant for high accuracy aspects, so you have to adapt to that particular domain to get those accuracies up. So those are the two things we noticed.
Robert?
So for me, when I look at AI for IoT, really, I look at the skills that are needed to deliver that. I mean, and when I look at this, my experience is that you need three types of skills. You need, first of all, the skills that are linked to your business. So your engineers, your domain experts, that is not moving away when you want to take benefit of AI. But you need to add to that what they call the deep AI core, or the core AI skills, which are the data scientists, the guys that are going to know which deep learning procedure they are going to implement. But this needs to be complemented with the right data. So you would need data management skills, data ethics eventually, and also the platform. For me, when it comes to bring AI to life, there is a fundamental question around which technology, which partner we are addressing those challenges, or which is the test bed for our data scientists and engineers to bring that to life. That being said, there is a third pocket of skills and people, which is the ones that are going to create meaningful experiences for users, to make sure that these wonderful AI algorithms, or these nice findings that we are able to learn and react, we consume them in the proper way. And that might be human-machine interface, that be machine-to-machine interface, that might be designers, that might be linguists, you name it. So, as we like to say, I mean, this AI is going to be the new UI.
Right, thank you. So really, the interesting part of it is that, artificial intelligence, AI, is not new, really, for a while now, right? So, but there's actually such a strong hype around AI. Can you share sort of your thoughts and why there's such a strong hype in the past 2-3 years? What actually sort of causes it, and how actually people should be thinking about it?
I can go first. I think it's the coverage in the media. Is at least in U.S. we hear when I talk to analysts and reporters, is it going to take away the jobs? This is a big rhetoric in the industry, and especially in the field that in which we are working, we're directly impacting the labor force for technician trying to fix things, right? So we feel that this is part of the skill that they have to enhance. These equipment are becoming more complex, so it's almost like going for education, right? So you need some assistance. So AI in our world is augmenting the human to do certain complex tasks better, and it is impossible for anyone not to have that assistance. And so, but the hype is there. I think it's about the real-world applications where this actually makes really meaningful, where you cannot really do without AI. I think that will change that perception.
I think in terms of robotics, there's always been a lot of hype involved with sci-fi films. I don't know if anyone has seen the film Passengers, where Michael
Yes.
Sheen performs.
Yes.
He's a wonderful barman in a spaceship which is heading towards the future. But and when you look at the Ridley Scott's Blade Runner, for example, which is supposedly was set in 1982 in Los Angeles in 2019, there's not much time left to 2019. And I don't think we're going to see the replicants which are in Blade Runner actually on the streets. But that's always been there, and now that AI is very much in vogue, I think there is an expectation that robotics and AI will enable these type of applications. I think we're a long way from that yet. I think they really, the fact that Michael Sheen played the robot rather than a robot playing the robot is an indication that we have a long way to go there yet. And we need to take it bit by bit. We need to actually see where machine learning and it can actually help robotics cases certainly, and offer information which is of useful and which can be combined indeed to enhance the user's workplace. I think that's more important than following the hype.
Yeah, definitely AI is here for, if there is a hype, it's because there is a business value behind it. So, in many areas on failures, on robotics, we have already been seeing those benefits. So it's going to be there where it's going to stay where it makes sense, and it's going to disappear where it doesn't. So.
So really, if I can sort of look at IoT and AI, I think they complement each other very well.
Very
right?
nice.
So if you like to sort of look at it, even in the context of robotics specifically, I pick one because robotics actually sort of encompass both sensing, acting,
Yes.
and thinking, right? Sort of all
Yes.
these pieces there. And
Yes.
IoT is actually, to me, the first stage has actually, we do a lot of implementations, mostly about sensing, it's about acting, maybe some level of prediction of sort. But then reasoning and how actually they all come together, I think is actually sort of very critical. The next stage in driving the IoT. So how do you see exactly that evolve? How do you see exactly people be able to push AI and analytics to the next level? Robert, you
So
want to
if I
start
may,
with that?
so, and when I hear IoT and I hear analytics together, I always think around edge analytics. So kind of, we have seen all the time, or for a long time, very sensorized machines, which had some type of reasoning there, so with the control systems and so. When, with the growth of UI, really, with AI, really what is going to enable is that the intelligence we can put in the machines, the ability for the machines to sense, learn, and react is really going to be huge. And we see cases of that with autonomous driving. We see cases of that really coming up. So really that part of reasoning that we can put at the edge is really key. That being said, also the part of learning that we need to do to get to the right inference engines at the edge is really where core deep learning will still happen. So really for me, is this balance between the edge and the center.
Anybody want to share?
Well, go ahead.
The reasoning aspect naturally came in our field because it's, at the end of the day, a human is interpreting these data, let's say IoT specific data, and these sensors can only tell you what are the baselines, what is the anomaly, and it's for the human to interpret that. But not only that, you have to interpret in a whole holistic context. So the IoT data will not have the full context. You know, it could be hidden in other enterprise data like servicing data and historical information, which will enhance that reasoning aspect. So for us, to actually help with anticipating the failures or guiding the technician to fix or a particular problem, we had to blend all of these together. So it naturally happened for us where we, early on, as you said, the IoT data wasn't taking us far enough to just come up with all the reasoning that is required. So we had to go beyond the IoT data to come to that conclusions. Yeah.
I think I'd just like to add that in terms of robotics, and certainly in an industrial environment, a robot is like a mobile sensor. Basically, it can act as an IoT hub, gathering together data which goes on around it, gathering cycle data, material consumption, and other items, and really is a fundamental part of any sort of an IoT architecture in that aspect. It becomes very interesting to implement robotics in that it automatically rules out possible manual transfer of data, which is always a source of error. And we see that both in industry and also a lot of the initiatives in retail, for example, to have robots running around interacting with people, are providing an opportunity to capture data about what people are up to. I think Amazon has that. Right. Has that very much online. That's very easy to do because you necessarily have to click. But in a bricks and mortar establishment, a robot can actually get some information about what people's likes are, what their preferences are, what they actually finally buy, etc. And I think that's very interesting from an IoT robotics point of view.
This is actually my last question. So after this question, I will actually open up the microphone to the audience here. So if you have any questions, let's actually prepare, and then we'll come back to you. So I believe there's actually a microphone somewhere. And if not, actually, we can actually sort of stand up and then just raise your questions, but just, prepare to ask questions if you like. So this is actually sort of questions to three of you. If you have, do you have any application systems that you believe that really embrace IoT and AI together, sort of this ideal application and how it could sort of look like, whether it is actually something that's now or the next couple of years that's actually sort of coming. What's your thought there? Do you have that, sort of symbol, sort of see how this actually AI will be able to bring IoT to the next level?
Well, if I can get in there first, I would have to choose the autonomous car, which I think is going to be really something which is much awaited and something which really does combine IoT and artificial intelligence and robotics to a great extent. And while we're waiting for the autonomous car, which I suppose will be sometime in the future both for technological and for legal reasons and other societal reasons, I think it would be, we should definitely bring that sort of technology to the factories and to our warehouses, which we already have, but we can actually perfect it in these environments, which are a lot less difficult than a mountain road or a road in Silicon Valley, the 101, for example.
I'll extend it beyond autonomous cars, connected transportation. If you take that as a broader topic, connected trains, connected cars, with or without autonomous driving capabilities. And the connected, use it with caution there. I mean, it doesn't have to be fully connected, even if it is semi-connected. The data coming from the sensors can add a lot more value, plus application of AI there is a lot more prevalent because, or makes it more useful because not only on the dimensionality of the data, plus the volume of data, and the techniques that are inherently scalable with AI, natural language processing, statistical machine learning, and these techniques at a large scale can be applied very nicely to help, in our case mostly, how do you prevent the failures, and so.
Especially in the context, the one that you mentioned earlier around human augmentation, so forth.
Yeah.
I think there's a lot of roles that AI can play from, how you're going to be able to interface with the system as you work in the car, for example,
Right.
all the way to how you're going to be able to help the person do the job, right, on site, and, suggestion, recommendation, skill set, and a lot of things that you can actually come
I mean,
there.
I can go with a specific example because in modern cars, even in the last couple of years, if you replace the tires and you do a wheel alignment, it is no longer your old wheel alignment. It has so many sensors around it. All these have to be recalibrated. The sensors that are impacting the cameras and the wheel angle position sensors. So it's getting very complex. Even the simpler tasks. And so AI can definitely help in kind of bringing that context back to the technicians or the servicing side of it to kind of be predicting these things and also be helping them in the day-to-day tasks.
Yeah, if I think on an industrial side, definitely the transportation piece, the autonomous driving, that's really very, very close by. But if I also look at more, if you will, the consumer side, or what is going to change a lot of people's life, it's about healthcare and how a lot of the sensors we all have and additional sensors we might have at home are going to transform the way we look at healthcare providing, the way we are looking at our health checks. So really for me that's another, and we're kind of case-based reasoning, a lot of knowledge corpus around, what is your medical condition. I think that's going to be another area where we're going to see a lot of traction as well.
Okay, with that, I will actually open up the floor to the audience here. Any questions, comments, anything actually we should be actually discussing? Yes, I see two hands, and maybe actually should step. Is there any microphone on the?
There's someone over here, Eddie.
Oh, there's actually a microphone, and there's a microphone there.
Hi guys, thank you so much for that introduction discussion so far. So I'm an analyst looking at the telecom sector, and I'm wondering if it's realistic for telcos to think that they have a role to play in providing IoT solutions embedded with AI, and if so, how would a telco with that, approach building that kind of capability or service from your perspective?
Shall I take a shot?
Yeah, go ahead.
So, definitely they sit in the pipe of data, so that puts them in a very good position. That's out of the question. They have the reach to the consumer place, so I think definitely there is a place for them to run.
We definitely get approached by a lot of telcos, and I wouldn't mention the names, but there is a kind of two tracks of things that are happening in the industry. Say connected transportation, because the pipe is through the telcos. They feel we could provide an ecosystem where a lot of partners can offer value-added services, including like predictive maintenance of the cars. So definitely there is a value for ecosystem that is going in that track. But parallelly there is, the OEMs are equally going advanced, with their own capabilities. If you take BMW announced BMW car data in Europe, and very soon it will be announced in US. So there is, I feel there are two different markets. One is OEM specific market, and then the other is aftermarket. where there's a lot more multi-vendor opportunities. So I believe the telcos do have a role to play if they're becoming the biggest player in that ecosystem.
Thanks.
Yeah, I'll just add on. I think the telcos, I think, have a very interesting position in terms of the customer data as well, right? I mean, they do actually have context to all the contents and who actually, all the communication happened, how long, and all the stuff. I think there's actually sort of very rich context that actually can add on to a lot of the background information to create more intelligent reasoning.
Yeah, your comment actually is a good lead into my question. So I want to get the panelists' take on the role of data and data ownership. Because we know that data will be used to build the models, whether they're machine learning models or to train deep neural networks, we need data. So what's your views on the role of data ownership and people having access to data to build better AI engines?
Anybody want to take on that?
It's one of the hottest topics in everywhere we go. So one, the data ownership is the primary anchoring based on which the regulations will take place, which if they haven't already, if you take GDPR in Europe and similar things in US. So I feel the OEMs will take a lead role where announcing that the owner of the data also has some level of permission-based, what we call opt-in to make the data available for other vendors. And so BMW example is another example. They have done that and they continue to do it. So, but it is not a solved problem yet. I feel regulations will soon needs to be more tightened up where the consumer is protected if the consumer is the originator of the data. And I feel there is a strong regulatory aspects will be coming ahead of us. So.
Anybody want to add?
Yeah, I fully echo what you said, but also at the same time, I think we are going to see kind of initiatives like data marketplaces where people could sell or give the right of usage of their own company data for a fee. So I think we are going to see a lot of interesting moves around that space because, I mean, in IoT, it's all about the ecosystem. So as long as we facilitate this enrichment, we're going to see much better products and services being provided to the end users.
Thank you.
By the way, there's at 3 p.m. on day 3, we have a panel specifically to cover that topic. Please come. I'm moderating that session as well, but it's very critical to talk about, especially in the context of GDPR, ownership, governance, ethics, a lot of rights to know, so a lot of good topics there, so please come.
I have a question. It's focusing around NB-IoT. I mean, I hear a lot about NB-IoT being really the long tail to scale IoT, but I know we're talking about industrial IoT, but when it comes to edge computing and artificial intelligence, which I think go hand in hand, how does NB-IoT play a role? Because those devices are going to be sub $5, they're, small computing capabilities, zero storage really, and very minimal throughput for mission critical data. How do you view AI playing a role with NB-IoT?
Any thoughts there? I add on my thoughts there. I think that would be really interesting, especially coming from the infrastructure side. I know that there's a lot of infrastructure providers here as well, in terms of building new generation of chips. They're out there that is actually like, if you actually look at what TensorFlow is doing, for, with Brainwave of Microsoft, FPGA, all these capabilities actually sort of getting into the edge as well. So that's actually sort of native process of machine learning, deep learning capability built into the edge, and that's like a lot of companies are working on that at this point. So it is coming. It's still likely, still fairly premature to talk about it from the industrial perspective, but certainly you can see a lot of intelligence actually pushing to the edge at this point.
Okay.
Thank you. All right, I think we,
One more.
question. Okay, we have 14 seconds, so it has to be fairly quick. All
Good
right.
afternoon. So you were mentioning penetration of artificial intelligence in transportation, but how would you explain the, I would say, paradox that there is much more penetration of artificial intelligence in road transportation, so cars and trucking, than into the rail transportation, which is much more organized, older, and then therefore easier to apply AI in this field? Is it marketing or?
Any thoughts?
So I think the question is in the traditional industries, it's harder to get in. We work with train industries, and the first place is in the maintenance and repair organization, where we're not getting into the regulations or aspects of it, but and the data is already collected, and we're able to apply those, the learnings back to the maintenance part of the business. So those areas is where it's getting easier to get in rather than getting inside the train or inside the vehicle. That's a lot more closed or difficult to get in. So that is our experience.
I think with that, we are running out of time. Please join me in thanking our three panels here. Thank you.